This third video is going to show you how to draw a slightly more complicated Lewis dot structure of a covalent compound. So for this one, we're going to do dinitrogen monoxide. Dinitrogen monoxide. Step one is we would add up all of the valence electrons for the atoms in the formula. So we have 2 nitrogens that each will have 5 valence electrons, 1 oxygen that's going to have 6, so this is 10 plus 6, that's a total of 16. That's step one. Step two, divide that number of electrons by 2 to get the pairs. So 16 divided by 2 is going to give us 8 pairs of electrons. That's step two. Step three is we're going to place the symbol for the least electronegative element in the center and surround it with the symbols for the other elements. I only have 2 elements, nitrogen and oxygen. Nitrogen is farther to the left on the periodic table, so it's less electronegative. So that means one of my nitrogens has to go in the middle. I can't have both of them in the middle, which means the other one's going to be out on one of the sides and the oxygen is on another side. So that's step three. Now I'm going to use 1 pair each to connect the non-central atom to the central atoms and subtract that from my total. So 1, 2, I'm down to 6 pairs left. That was step 4. I'm going to put pairs of electron dots on the non-central atoms to fill their octets. So here's a pair, here's 2 pairs, here's 3 pairs, and that fills this octet. So now I'm down to 3 left. So I'm going to put 1 pair, 2 pairs, 3 pairs, fills that octet. I have no electron pairs left. So that's step 5. If you have extra pairs, nope, move on. If you ran out of pairs, yes I did. Check each atom for an octet. Yes, you have an octet. No, this one doesn't. 1 bond and 1 bond, that's a total of 4 electrons. I don't have an octet, but this one does. So I can move lone pairs to form double bonds as long as the elements that I'm connecting can both make double bonds. So there's that CNOPS mnemonic device. I'm dealing with nitrogen and oxygen. They're both in CNOPS, so I can make double bonds. So what I would do, what if I take one of these, make a double bond there. So let's get the eraser tool. So these are no longer non-bonding, they are now bonding electrons. Okay, and then let's do that on the other side also. Let's just move this pair here. So get out the eraser. And these are not non-bonding anymore. They're bonding. So now let's check for an octet. This would be 1, 2, 3, 4, 5, 6, 7, 8. Perfect. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. 1, 2, 3, 4, 5, 6, 7, 8. Awesome. Everything has an octet. Let's move on to the formal charge calculation. So for formal charge, I have to take the number of valence electrons and subtract the non-bonding electrons and the number of bonds. So let's just go left to right. For this nitrogen, 5 valence electrons minus 1, 2, 3, 4 non-bonding and also 2 bonds. So 5 minus 6 is going to give us -1. So this formal charge is -1. Now let's do the central nitrogen underneath it. So nitrogen's 5 valence electrons. It's got no 0 non-bonding electrons and 1, 2, 3, 4 bonds. So 5 minus 4 will give us +1. So let's put +1. Okay, now let's do oxygen over here. Oxygen has 6 valence electrons minus, it's got 1, 2, 3, 4 non-bonding electrons and 1, 2 bonds. So 6 minus 6 gives us 0. So the formal charge on that oxygen is 0. Well, the formal charge on each atom is not 0, so we have to move on to, if the formal charges are not 0, but they add up to 0, see if you can move electrons to make double bonds. Well, I already have a double bond, but let's see if I can make a triple bond and see if I could bring the formal charge down and this guy up. So let's try moving these 2 electrons here to make a triple bond. So let me get my eraser tool out. So these are not non-bonding anymore, and this is not going to be the right formal charge anymore because I've moved stuff around. But before I move on, this now has an expanded octet because it's got 2, 4, 6, 8, 10 electrons, and that can't happen. It's not in the 3rd period or higher. So I'm going to have to move this double bond back to being a non-bonding pair here so that we can see if this works, right? So let's change color. So for take 2, This nitrogen has 5 valence electrons, 2 non-bonding, and 3 bonds. So 5 minus 5 is 0. That's an improvement. Let's try the middle guy. 5 valence electrons minus no non-bonding electrons and 1, 2, 3, 4 bonds. Still going to be +1. So now we have to try the oxygen because we changed something. We took a double bond and made it a non-bonding pair. So it had 6 valence electrons minus it's got 6 non-bonding and 1 bond. So that's 6 minus 7. That's -1. So this guy's formal charge is not 0 anymore. The formal charge is -1. So they aren't 0, but they add up to 0. So if I must have a formal charge, make sure that the negative is on the most electronegative element in the formula. It is, right? Oxygen is more electronegative than nitrogen, which is why we couldn't put it in the middle. So it looks like this is going to be our correct Lewis structure for this compound. So the last thing we do, we move on to step 9. Here's our Lewis structure. We have to count the electron domains on the central atom. So let's highlight. In this case, we have a triple bond. That's not a highlighter. We have a triple bond and we have a single bond, right? Here's our triple bond. Here's our single bond. So that's 2 electron domains. 2 electron domains. And you'll learn later what we're going to do with those electron domains.